Okay, so today we're going to deal with confidence intervals again, and this time we're going to work with X bars instead of proportions. So here's most times what we're going to have to do. We're going to have to decide if the conditions are met. If the conditions are met, then we're going to make a confidence interval, and then afterwards we're going to need to interpret what that confidence interval means. So the very first thing we have to do is state whether the conditions are met. So the first one we need is independence. We need to make sure it's random. And we need to make sure it's going to be normal. So I check independence by the 10% rule, that we don't take a sample that's bigger than 10% of the population. So they have 100 students selected from a certain school. So we just have to assume that the school has over 1,000 people. So we're just going to have to assume that's true, that if there is over 1,000 people, then we're good. We're going to assume that is, so check. The next thing that we have to look for is random. They said it's a random sample, so that one checks off. And the last thing we need is it's bigger than normal. For ones that we're looking for X bars or means, that's where we say that n has to be greater than or equal to 30. So we have 100. That's greater than or equal to 30. So we have pretty much checked off the first condition, or the first thing, that all the conditions are met. So let's move on to calculating the confidence interval. So they want a 98% confidence interval, which means they want to get everything in here and have 1% left on the ends. So that's what they really want. They want about 1% left on the ends. So let's create that confidence interval. For X bars, X bar will be our point of interest. We are going to do plus or minus the margin of error. The margin of error is made up by the Z critical value, which we'll find in a second, and the standard deviation, which is the population standard deviation divided by the square root of how many samples we take. So when we fill that in, we know that they told us the mean that they found was 112. So the school is above average in IQ. Plus or minus the standard deviation of the population. They said the known standard deviation is 11, so we're going to say 11, and that's over the square root of 100. And now we'll have to times that by the Z critical value. Here's how you find the Z critical value. You need to go to the Z table, and unfortunately the Z table only gives you this little tiny portion, and we want 98%, so we don't want to look for 2%. We know that each side is going to have 1%, so when I go to 1%, that's going to be around 2.3. If we want to get real exact, it'd be 2.32 probably, which is right here on the table, that 1% right there. So when we calculate this, we'll have 112 plus or minus 2.32 times 11 over the square root of 100. So that would be 112 plus or minus, and then we'll just throw all this into a calculator. So 2.32 times 11 divided by the square root of 100. I guess I could have just put 10. But so plus 2.5. Okay, which gives us a nice interval. Here's what we would say if we want to interpret what this means. We'd say we are 98% confident that the true mean IQ of this school, so this is again context, and we want to make sure that we're saying mean instead of anything else. It's not the true value, it's the true mean. IQ of the school is between this interval. Probably using the words contained in would also be fine. But we want to make sure that we're using the words, again, confident and then mean. Okay. Here's one last thing that we're going to have to be able to do. We want to make sure that we're able to pick our size that we want of our margin of error. So a lot of times you want to pick your margin of error size, and so that's the very, very last thing we'll do. Let's say we want to keep a 98% confidence interval, but this time I don't want my margin of error to be so big. Like, that's pretty wide, like 2.5. Like, maybe I just want to be off by, say 1 like 1. So let's say we want our margin of error to be 1, and I still want a 98% confidence. So if we have to do that, we'd have to go to our margin of error and say, okay, we would still, since it's a 98% confidence, have 2.32 times our standard deviation, which can't change, but the number of samples we can change. So we're going to change our number of samples, and we said we wanted that to be 1. If I want to do that, what I'm going to have to do is I'm going to have to divide by 2.3 to get that by itself. We would then have 11 over the square root of n. I would times this n up over here, and then divide this to the other side. So we're going to have 11 divided by 1 over 2.32, which, let's kind of do that. So 25. And that's the square root of n. So we're going to square this thing, square this thing. So we would have needed to take a sample size of 625 to get a margin of error of 1. And we can do that as long as the school's population has over 6,000 students. So we might not be able to get the margin of error that low with a 98% confidence interval, but that's how we would have to go about figuring that out. So the big thing for today is you want to make sure you state the conditions that are met. You want to calculate the confidence interval, and the formula we're going to use for confidence interval will be this one right here, because I accidentally just lost my other one, but that's what we're going to use. You're going to find your z-star by picking the percentage that's on the ends, and after you have calculated all of that, you're going to want to interpret and make sure you're using means or words like confident and mean. So that's kind of what we're going to do for today.